When I started to look for what I want to do when I'm big, I didn't know exactly what would I want to do because I really liked maths, physics and chemistry, and there's a lot of fields that covers those three topics. But then I discovered that they teach also space systems engineering in Finland, and that was the moment that, wow, this is something I really want to learn. ESA got the contribution for Hera in 2019 when we got the funding for the project. And after that it was rewarded to OHB, who's also now working here in the background. And then what we do is to look for the reviews, what kind of reviews we have, and also the documentation that everything is in place. And of course now we are really pushing to have the launch readiness before October when we launch. So what you're seeing here is Hera. So here you have the two asteroid framing cameras, and between them you have the Japanese instrument TIRI, which is a thermal infrared imager. Then we have just behind them we have two star trackers, and there's a hyperscope, it's also a camera. Then we have two kind of silver rectangular, and behind there are the two CubeSats, which are called Juventas and Milani. So when we get closer to the asteroid, we will release those CubeSats, and they can go even closer to the asteroid to observe the surface of the asteroid. Then we also have, in the middle, we have the planetary altimeter, which we will use then for the automatic navigation. So that will measure the distance from Hera to the asteroid, and we will navigate automatically. My contribution to Hera is to make sure that whatever goes inside Hera will survive the space environment. And I have a team of experts who helps me to define that everything is okay, they will survive the space environment. I will also make sure that any equipment has gone through qualification testing successfully, and we can then put them in Hera. I think the biggest challenge is to combine the CubeSats and Hera, because Hera is so-called old space and the CubeSats are the new space. The CubeSats are following more industrial rules, and Hera is really following the standard ESA rules. So combining these two together, so that making sure that there's no failure propagation from the CubeSats to Hera has been challenging. The biggest challenge of this project, because this is the first time for me, at least, when we are putting the CubeSats inside spacecraft. It's because the CubeSats they are more rapid. They don't follow all the rules as we would like them to do, and we cannot even impose all the rules for them, because then they would take much longer to build the CubeSats. So we make sure that the processes they are using, they are traced. The components are not as rigid as we use for the Hera spacecraft, for example, but they need to go through radiation testing, so that we know that there won't be a problem when they go to space. But they are using commercial automotive components. It's starting to get more and more common that because CubeSats can take more risks, that we are launching more and more CubeSats, because they can go closer to the target where they want to go. Like this case, they go closer to the asteroid, and at the end they are landing to the asteroid, so which we cannot do with Hera, because Hera is the one who's relaying the information from the CubeSats to Earth. One of the threats which Hera could see was, of course, we have a long cruise phase. So we launched this year, but then we have 2 years that we are cruising towards the asteroid. And we don't know, maybe there's solar flares, maybe there's some space debris that could hit Hera. It's really unlikely, but it can happen. So that would be the most threat to Hera on its journey to the asteroid. So it goes through all the testing, all the TVAC, EMC testing, vibration testing, all the testing it has gone through like any other satellite. Of course, for the CubeSats, they go separately first separately through all the testing and then combined with Hera. And this is then the test cap so that the radio waves don't get out, so it's safe for humans to be here.
Okay.
Because otherwise we should be in the chamber. Okay. That's actually what we did last week. We were in the chamber to test it without the test cap. You can also see there's the red covers here. Those are covering the thrusters because they're quite sensitive, so if you hit them, they break. So those are to cover, and it's for all the corners, because we use them in case we see from the astroframing cameras that we are drifting away. Then we can adjust with the thrusters that, okay, we have to move Hera a bit this way or that way. And there, of course, you see the launcher interface. And actually, SpaceX is coming to do the separation test here, that everything's fine, and they know that we actually can separate it from the launcher. Here you only see the silver, like a cover. There's the smaller antennas, which we use for the CubeSats,
Okay.
the communication with the CubeSats. So we have 2 here and 2 on the other side. Well, I think the collaboration with all the teams, especially when we only got funded 2019 and we are 2024, Hera is here. We are almost ready to go for launch. I think that's really amazing teamwork for all the industries who were involved.